everyone, welcome. Today we will be discussing electrochemistry, which is a major high-yield concept on the MCAT, and we'll be talking about the galvanic/voltaic cell or battery, which is where you're bound to see most questions come in regards to electrochemistry. So let's get started. So we have two pieces of metal, chromium and gold. Obviously, these two are not going to have the same level of positivity or how positive they are. In this case, chromium is less positive than gold. Gold is more positive. So now if we think of this in terms of redox or reduction and oxidation, which is another high-yield concept on the MCAT. If we think of this in terms of redox, if gold is more positive, that means that it's going to want electrons more, right? And the gain of electrons, if we look back to Leo the lion goes grr, where loss of electrons is oxidation, gain of electrons is reduction. We're going to be gaining electrons because the more positive we are, the more electrons we want. We become an electrophile. So that would be reduction. But this is still positive, right? So it still has a reduction potential. It's just less. So we need to look at these in terms of their reduction potentials. Reduction potentials. And like I said, because gold in this situation has greater positivity-ness, if that's even a word, than chromium, gold is going to have a greater reduction potential. So let's say the reduction potential of gold is, negative 0.74. Let's just say that. And for chromium, it's going to be less, so let's make it negative 1.5. Now, as I said before, the gold is going to want to take more electrons, right? And in a galvanic cell, the electrons are going to come from the other metal. So the electrons are going to flow from the less positive metal to the more positive metal, because this one wants to become reduced, right? So this place where reduction is occurring is called a cathode. Another way to remember this is the mnemonic red cat, reduction cathode. So this is the cathode. And this side, since we're giving away electrons, this is going to become oxidized. And that occurs at the anode. So we have anode and cathode, and the flow of electrons is going to be from the anode to the cathode. Anode to the cathode, because we are taking electrons from the less positive thing to try to get some negativity in the more positive thing. Now, how can we determine if this flow of electrons is going to be spontaneous or not? So spontaneity is going to be in terms of the reduction potential of the cell. So that is going to be called the E of the cell. If it's greater than 0, that means we have a spontaneous reaction. So the electrons will willingly flow to the other side. And if we have one that's less than 0, that is non-spontaneous. So it is not willingly going to flow onto the other side, right? So now in terms of the galvanic cell, we are not just going to have these two metal pieces floating, right? We are going to have them in solution. We're going to have them in solution, and the solution is always going to have the ions of the metal. So in this case, Cr3+ would be the ion for chromium, and Au3+ would be the ion for gold. And like I said, the electrons are flowing from the chromium to the gold. Now, as we are having more, let's zoom in. As we're having more electrons over here interacting with the gold, we're actually going to form more solid here because there are interactions here, right? So we're going to form more solid here. And since the electrons are getting added to the Au, we can write the reaction Au 3+. We're getting a bunch of electrons, right? So plus 3 electrons which is what we're getting from the chromium over here, is giving us the solid form of Au. We have a bunch of solid forming in because these electrons are interacting with the gold bar. Now on this side, it's kind of the opposite situation. We're losing electrons, so it's going to eat away at the solid structure. It's going to eat away. So we're losing solid on this side, we're losing solid on this side, we're gaining solid on this side. So in this case, chromium solid is actually a reactant, and because we are losing our electrons, the electrons are going to be on the other side. So in the gold, we are gaining electrons, hence why it's on the left side of the reaction, and for the chromium, we are losing electrons, hence why it is on the other side. And we're also forming solid on the reduced side, and we're losing solid on the oxidized side, or the anode. So that's why we're breaking down the solid over here, and we're forming the solid over here. Now, what if they give us a question in which we're trying to figure out whether something is spontaneous or not, right? So we're probably going to get a question on the MCAT where they ask us, is this reaction spontaneous or not? They'll probably ask us to write a reaction as well. So let's keep this chromium and gold idea in mind, and let's move on to an example. And this is actually taken from the official AAMC practice exam number 1, and it is question 55 of the Phys Chem section. So full length one. Let's write full length here. Full length one. So they give us a reaction, and it is 2B plus aqueous plus 2E minus Cu2 plus AQ plus 2E equals plus 0.339 volts. So because they gave us the E reductions of these two reactions over here, we can figure out which side is getting reduced, which side is getting oxidized. So let's see. Over here we see we have a negative reduction potential. And negative reduction potential means that since it's negative, it means that it's going to be non-spontaneous. Non-spontaneous. So it is not likely for the side with PB to get reduced because it's non-spontaneous. So it's not gonna, the electrons are not going to readily flow to the PB from the Cu. It's not going to readily flow this way. And why is that? That's because the E is less than 0, so it's non-spontaneous. Now let's look at the copper side. So we'll see we have a positive E, and that means it is spontaneous. It is spontaneous, so that means that the electrons are going to willingly flow this way, right? So now we know which direction the electrons are flowing. We know the electrons are flowing from PB to Cu. So we do have a flow of electrons. So now if we think of it in this way, looking at the example we had earlier, we can pretend that this is, so we're flowing to Cu, right? So we can pretend that this is Cu, and we can pretend that this is PB. So we have our same situation. The electrons are flowing to Cu. So that is accurate. We figured out what direction it is flowing in. Now, using that, we can actually answer the question that was asked. The question that is being asked here is, given this information, will an oxidation reduction reaction occur spontaneously? Well, in order to do that, we need to find not just the single reduction potentials, we need to find the reduction potential of the entire cell. So we need to find E cell. Now here's the formula you should know. E cell is going to equal the reduction potential plus the oxidation potential. Now you might be confused over here. We didn't talk about oxidation potentials, did we? We only talked about reduction. But there's an easy part of electrochemistry that will help us find the oxidation potential. The way we find the ox potential is just by taking the negative of the reduction potential. Right? So if we look over here, we have reduction. So what is being reduced? We have this. We determined that the copper was being reduced because the copper is spontaneous. So there's a spontaneous flow of electrons. So the copper is being reduced. So we know what to write over here. We can write 0.339. Now we need to find what's being oxidized and the oxidation potential. So because we determined that the copper is being reduced, we know that the lead is being oxidized. And they gave us a reduction potential of negative 0.127. But since we're looking for the oxidation potential, all we need to do is take the negative of that. So that becomes a positive. So now we have 0.339 plus 0.127. And that's going to equal 0.446 is the total reduction potential of the cell. Or the total potential of the cell, my bad. I think I've been saying reduction potential of the cell, but it's technically the sum of the reduction and the oxidation potential. So let's just call it the electrochemical potential of the cell. So we have 0.446, right? So let's answer this question. This is the question we got. Will an oxidation reduction reaction occur spontaneously? Well, because we have a value that is greater than 0, yeah, it will occur spontaneously. It will occur spontaneously. So our answer here is yes. And the specific E cell value we should have gotten is 0.446. So there you have it. These are the types of questions that you might be asked regarding electrochemistry on the MCAT. And I hope that was helpful.